In this video, you will learn about isomers and the different types of structural isomers. Isomers are compounds that have the same molecular formula but different arrangement of atoms. Isomers can be broadly classified into two types: structural isomers or stereoisomers. Structural isomers have different bonding arrangement of atoms, while the stereoisomers have the same bonding arrangement but different spatial orientation in the 3D space. In this video and workbook, we'll confine our discussion to structural isomers. Structural isomers are of three types: chain isomer, position isomer, and functional group isomers. Chain isomers have the same molecular formula but different branching in the carbon chain. You may recall the naming of straight chain and branch chain hydrocarbons in earlier videos and workbooks. For example, if you have a molecular formula C4H10, there are two possible chain isomers, butane and methyl propane. Or if you have a molecular formula C5H12, there are three possible isomers: pentane, 2-methylbutane, and 2,2-dimethyl propane. So here you can see the branching is increasing. Or if you have C6H14, then there are five possible isomers: a straight chain hexane, 2-methylpentane, and the position of the methyl group changes, so it's 3-methylpentane, further branching with 2,3-dimethylbutane or 2,2-dimethylbutane. You might want to pause the video and draw all possible isomers of C7H16 and C8H18. Position isomers. In these isomers, the carbon skeleton is the same. However, there's a difference in the position of the functional group, or the double or triple bond, or even the position of halo substituents. In this example, the two compounds 4-methyl-3-pentanol and 4-methyl-2-pentanol have the same molecular formula. They're both alcohols and they have exactly the same skeletal structure. But the position of the OH group is different, and therefore they are position isomers. Or in this example, the position of the triple bond is different in 2-hexane and 3-hexane. Or in this example, the position of the bromo substituent is different in the two compounds. And therefore, these are examples of position isomers. Then we have the functional group isomers. These are compounds that have the same molecular formula but different functional groups. For example, we have alcohols and ethers. This is the general formula where R is the hydrocarbon part of the compound. So in alcohols, there is one R group with an OH, and ethers have two R groups with an oxygen. So ethanol and methoxymethane are examples of functional group isomers. Aldehydes and ketones. C4H8O could be a butanol, that is an aldehyde, or butanone, which is a ketone. Similarly, carboxylic acids and esters are functional group isomers. So C4H8O2 could be butanoic acid or methyl butanoate. So in this workbook, you can practice questions on structural isomers. So good luck and enjoy.